Okay, welcome back, everybody, to Architecting Software, the SEI way, essential steps toward mastery. Our next presentation is Analyzing and Evaluating Enterprise Architectures by John Klein. Before I read John's bio, I just wanted to go back to a quick question a couple people had as we were signing off from the last presentation, asking about the LinkedIn groups again before we signed off. There is a Saturn LinkedIn group as well as an SEI Series Forum LinkedIn group. You can just search on either of those names, and it will be an easy find. John Klein has over 20 years' experience developing software, systems, and software. He joined SEI in 2008. Before joining the SEI, John was a chief architect at Avaya Incorporated. There, his responsibilities included development of multimodal agents, architectures for communication analytics, and the creation and enhancement of the customer interaction software product line architecture. We'll turn the presentation over to John. John, all yours.
Thank you. All right, so today we're going to look at some essential problems for architects. If we believe that good architectures satisfy business goals, then we have a problem of how do we translate those business goals into quality attribute requirements. And we think that architecture is the result of decisions. The structures in an architecture come from decisions that architects make. And so many of those decisions are trade-offs that promote one or more quality attributes over others. So how are we going to evaluate the architecture to ensure that the decisions embodied in the architecture actually do satisfy our business goals and support the right quality attributes? I'll be talking to you today about some results of analysis and evaluation of enterprise architectures that come out of some ongoing research that we have here at the SEI in the Architecture-centric engineering initiative. That's part of the Research Technology and System Solutions program. The work I'll be presenting has been proven out over a number of customer engagements, but it is still evolving. So we create systems in order to satisfy certain business and mission goals. And architecture is the enabler to make that happen. We design an architecture that's based on quality attributes to support our desired goals. And we can evaluate the architecture to see if it's going to satisfy the goals. And then we use that architecture to implement the system. And we want to ensure that the system we build conforms to our architecture. And this model applies at the system and software level, also applies at the enterprise architecture level. I'd like to start with a brief recap of the principles of software architecture-centric engineering. And these apply to both software and systems, also to systems of systems and enterprise architectures, all types of architectures that we look at. And the first of these is that every system has an architecture, regardless of the scale of the system and regardless of whether that architecture is explicitly documented or not. So the architecture is a property of the system. The documentation is something that we create. The architecture can be intentional. It can be something that we do actively design and maintain, or it can be accidental. If we don't do anything, the architecture will just happen anyway. The next thing I'd like to point out is we don't need to build the system in order to reason about it. Okay? So the architecture, we're going to define that as the structures that we need to reason about the system, and those comprise the elements, relationships among the elements, and the properties of both. Given the architecture and the architecture documentation, we can evaluate it. Quality attributes have a dominant influence on the system's architecture. Quality attributes shape architecture. We'll be coming back to that throughout today's presentation. Function is important, but it's really the quality attributes that govern the architecture. And finally, when we talk about drivers of system change, these can be explicit things that we anticipate in how our business and mission goals are going to change, but these also relate to how our organization and the technology that we're using to implement the system change. So I'd like to take a quick review of what we mean by quality attributes. Now, many of you may already know this, but there may be some people here who aren't as familiar with the terminology. So quality attributes are the properties of work products that stakeholders use to judge the quality of those products. You may see them referred to as non-functional requirements, NFRs. Sometimes I've seen them referred to as illities, and that's because many of the names of these quality attributes end with the syllables illity. So we've got a list here of some example quality attributes: security, performance, modifiability, reliability, others. And these are taken from our work in software and systems, but they apply to many other types of architectures as well. These are not a complete list of quality attributes. And in fact, there is no complete list. The quality attributes that are important to you are going to come from your business and mission goals. And there are some places, though, that you could look for inspiration as you're trying to figure out what quality attributes you need to focus on. So some of those places are the Software Engineering Institute's literature. And we focused on 6 particular quality attributes: availability, modifiability, performance, security, testability, and usability. We found those are quality attributes that appear in almost every system that we've looked at. There's something called the LaPrix taxonomy for dependable systems. If you Google that, you will get to a paper where they look at reliability, availability, safety, confidentiality, integrity, and maintainability, and build out a list of quality attributes under that. You might also look to the standard ISO 9126 as another place where there's a list. As you go through these different pieces of literature, you'll find there's a lot of overlap. There are a lot of things that seem to have different names for the same quality, and I'll get back to that in just a second. But these are some places to start with. And the other place that you get your quality attributes from is to look at your business and mission goals, talk to your stakeholders, and find out what is important to them. What are the qualities that they're using to judge your system? We said functionality is important, but quality attributes shape architectures. So what about functional requirements? Functional requirements define the work that the system is intended to do. It's the what. And then quality attributes are the how does that get delivered. In talking with people, this is sometimes a hard thing to understand. So one example that I use is automobiles, right? The function of an automobile is to get you and your stuff from one place to another. But yet, everybody has a different kind of car. And if you look at the automobiles, they all have different architectures. We find automobiles that have front-wheel drive, rear-wheel drive, all-wheel drive. Why is that? They all get you from one place to another, you and your stuff, but different qualities. Some people have a quality that they've got to be able to do it in all kinds of weather, snow and ice, and they may want all-wheel drive. Other people want something cheaper and simpler. They'll take just rear-wheel drive or front-wheel drive. We see different sizes of cars, big cars, small cars. They all get you from point A to point B. But, you know, a smart car, little smart car is really easy to maneuver and park in the city. Other cars have a little bit more room if you've got more stuff to carry. So, again, same function, different quality attributes leading to different architectures. We see that in software systems as well. If we take software systems like LinkedIn, Facebook, Google+, they're all social software systems. They all have similar sets of capabilities. You can set up relationships between you and your circle of friends or colleagues. You can like things. You can comment on things. But if we peel those systems away, we find fundamentally different architectures underneath in the way the data is stored and distributed, the way changes are propagated. And that's because each of those systems has a different priority in their quality attributes in terms of consistency of what everyone sees, in terms of the speed of updates, in terms of what they're looking at in terms of scalability. So different systems with similar functions have different architectures because of different quality attribute prioritizations. I said earlier that often we'll see that the quality attributes, if we looked at those different inspiration points for quality attributes, the same name being given to different things or different things seeming to have the same name, names of quality attributes are problematic. As an architect, you often have someone come up to you and say, this system has to have, I'll just use an example here, high performance. And they're very passionate about it. Maybe it's your product manager, or one of your marketing people. Maybe it's one of your other development colleagues. But you know, they're really hung up that the system has to have good performance. What does that mean? Well, you know, if you start peeling it back and ask them, you know, what do you mean by good performance? Well, it's got to be really responsive. Well, you know, what does that mean? Well, when a user hits the submit button, we got to give them feedback within a second. All right, so we've gone from something that's very general, good performance, to something now that, as an architect, I call actionable. If somebody says when the user hits the submit button, we need to provide some visual feedback within 1 second, well, that's something I can do something about. Good performance, very general. You know, what parts of the system have good performance? Is it the end user interface, or is it the management interface, or is it the interface that I use to migrate the data from one version to another, something that may be really unimportant? We need to know where to focus. I once sat at a meeting when I was working in the telecommunications domain where people were discussing a particular quality of the system. And one person said, well, it's all about performance. The other said it's all about call volume. No, it's all about transaction rate. No, it's all about throughput. No, it's margin. No, it's headroom. No, it's really availability. No, it's really usability. And everybody was talking about the same thing. And so if we're just using these names, it gets hard for us to know what to do about it. So our solution to that is to use quality attribute scenarios. Quality attribute scenarios are a short description of how does the system respond to a particular stimulus. And they complement use cases and user stories. Use cases and user stories, again, are focused mostly on functionality, what the system has to do. Scenarios focus on the quality attributes. How do we deliver the functionality? And they complement each other. The stimulus for a scenario can come often from a use case or a user story. So that'll give us the starting point. And just a quick review, scenarios have 6 main parts. And I'm going to take these a little bit out of order from the way they're numbered on the slide and take them the first group of stimulus, response and response measure, and environment. These 3 things together, or 4 things together, are the most important part of the scenario. So we're going to start with those when we're talking with our stakeholders. And then if we can find the source of the stimulus, where did it come from, and what are the artifacts in our system that the stimulus is sent to, those will give us some additional information that we can use. So quality attribute scenarios, these short stories in a structured way, give us a way to understand the quality attribute requirements for our systems and software. So this is technology and methods that have been around for a while. We have at the SCI the Quality Attribute Workshop as a systematic way of developing quality attribute scenarios with your stakeholders, and the Architecture Trade-off Analysis Method, or the ATAM, as an evaluation method that uses these scenarios to test an architecture. So what I'd like to do now is step from systems and software to something called systems of systems. Now, a system of systems is a larger scale thing. It's a system that is built by putting together components that are themselves other systems. But what makes a system of systems different from other large-scale, complex things that are built from large-scale components? Well, Mark Mayer at the Aerospace Corporation had postulated two criteria that distinguish a system of systems from other complex things. And this definition has been largely accepted by the community and used by most people and has proven to be useful. So what he proposed is that these systems have operational independence. They can operate independently to perform some useful function. And they do actually operate independently. They have managerial independence, or they work under different authorities. And when we put these two things together, it gives us a context that is different from just dealing with even a large, complex piece of software. This idea that we have elements that perform multiple functions at the same time and are being controlled either at development time or at runtime or both independently of each other. We see this frequently in enterprise IT contexts. Systems serve multiple purposes with different stakeholders, different business drivers for these systems. So things like a customer relationship management or a CRM system within a business or an IT enterprise is going to support marketing, sales, post-sales customer service. Systems like workforce management are going to support both timekeeping, payroll, compliance, maybe HR. If you've got a data warehouse, that's going to be supporting all or many different business processes and participating in many different kinds of workflows. So we often frequently see this system of systems within enterprise IT. If we take this perspective, then it provides some insight. So Mayer's work continued, and he identified four design principles that can help us succeed in this challenging environment where we have systems of systems. The first of these is stable intermediate forms. The idea that either in development or at runtime, there are configurations that are stable, points where we can stop and integrate and do testing and prove out. Principle of policy triage. These are large, complex systems. Where do we focus our attention? Leveraging at the interfaces. Interfaces are always important in architecture, but for systems of systems, they become particularly important often as an architect. This is the only place that you have leverage, the only place that you can enforce how things are going to interoperate. And the last principle, ensuring cooperation. And this principle hints at, through this reference to incentives, if systems require voluntary cooperation, the mechanism and incentives for the collaboration have to be built in. This idea of incentives hints at another perspective that I'm not going to cover today. I'll just mention the ultra-large-scale system perspective. This is other work that we've done at the Software Engineering Institute, ultra-large-scale systems, or ULS systems. These are systems of systems of unprecedented scale where the interaction between the elements becomes even more virtualized than we're typically looking at here. So yet another perspective that you can take that may help. So we'll come back to systems of systems in a couple of slides. But let's move now to look at enterprise architecture. So let's define enterprise architecture first of all. There are many definitions of enterprise architecture. And in fact, there was recently some extensive discussion about the definition of enterprise architecture on Wikipedia. So if you're right now Googling enterprise architecture and you get to the Wikipedia page, I'd encourage you to look at the talk page as well as the article page. The talk page has some of the discussion between a number of contributors to Wikipedia that gives you some insight into what do practitioners think enterprise architecture really means. The definition that we're going to use comes from Jean Ross and her colleagues at MIT Sloan School of Business. The reason that we've adopted this is in 2010 we held a workshop with some enterprise architecture practitioners, and although we didn't want to get into a definition discussion, we wound up there, spent some time, and this one seemed to resonate with the most people and proved useful for a couple of reasons. One reason is that the four constituent architectures identified, the business process architecture, data architecture, applications architecture, and technology architecture, technology or infrastructure, are similar to other sub-architectures identified by groups like TOGAF. So this aligns with the TOGAF definition, which many people also use. Another reason is that this definition explicitly addresses some of the confusion. So as Ross says, the term enterprise architecture can be confusing because the IT unit in some companies refers to one of the architectures or all four of the architectures as the enterprise architecture, when in fact the enterprise architecture sits on top of all of this and relates these four things to the actual business operation of the company. So the four architectures listed here support business operation, and the way they support the business operation is the way Ross defines enterprise architecture. As I said, there's been a lot of discussion in the practitioner community recently. Look at the talk page on Wikipedia. That'll give you some background there. So why did I talk about system of system architectures? Well, because the four parts of the enterprise IT architecture together or each of them constitute a system of systems. So we can view each of these or all four of them together as a system of system architecture. And taking that perspective is useful for us for analysis and evaluation. And, particularly in many organizations, some of the elements of these architectures are outsourced. We can think of, what constitutes a system of systems. Well, independence of management. If we're outsourcing, we definitely have managerial independence. Often the systems within an enterprise are coming from mergers and acquisitions of other companies. Here we have certainly operational independence. They're performing different functions for different stakeholders. There are many cases where we directly see a system of systems within here. Sometimes the enterprise itself is extremely virtualized. We see enterprises today that operate with an eBay storefront. They use UPS for all of their logistics, and they use a company like Intuit for their payroll. And the whole thing is run by three people with laptop computers who never actually touch the products that they sell and ship. So, in that case, there's certainly independence in each of those. There's an architecture that ties it all together. So taking a system of system perspective can be helpful. And if we go back to the design principles for systems of systems, they can certainly help us when we're thinking about enterprise architectures, right? Enterprise architectures have some unique concerns. The first of these is that enterprise architecture is almost never a greenfield project. We're always having to deal with as is, to be, and the path from here to there. And so if we look at the principle of stable intermediate states, that helps us in thinking about how do we get from here to there. Let's do it in discrete, well-defined chunks with stopping points where everything works. Enterprise architectures are socio-technical systems. We have humans in the loop. We're taking business processes. We have to make decisions about what do we automate, what do we do manually. And humans in the loop bring us different failure modes. We now have to account for human error, which comes in all sorts of different flavors. But it also gives us different recovery modes. We have manual intervention now as an available recovery mode. And so our architecture has to account for those. We have design time concerns and we have runtime concerns. One of the things we need to pay attention to is the idea of mirroring, or Conway's law, where the organization that is building the system, the structure of that organization gets reflected in the system that gets built. And in particular, where we're doing outsourced development, or we've got different multi-site development, these kinds of things, it has a perhaps larger impact in enterprise architectures. It's a complex environment. Systems play different roles. Usually they're playing these roles at the same time. So we have a repository, for instance, that's doing online transaction processing, but there's also an interface that allows us to do batch mode extract or loading of data. These things are happening at the same time. We need to account for those relationships between systems that can be both direct and indirect. And finally, the scale of enterprise architectures often leads enterprise architects to focus on policies as much as they focus on structure. So we're looking at rules of engagement. How do we define interfaces? What are the things that we're going to focus on, focus our attention on, rather than necessarily the way we might architect a piece of software or software system where we actually sit down and define modules and components and connectors. So a little bit difference in the level of focus. So in dealing with enterprise architectures, we said earlier that quality attributes shape architectures. We asserted that that is at all scales of architecture. So architects need to understand quality attribute requirements. How do they do that at the enterprise level? So we've developed a tool called the business thread. The business thread describes an end-to-end flow throughout the enterprise. It's usually encompassing multiple business processes. So examples, quote to cash, or from shopping to order fulfillment to returning product, or in a clinical setting, like a hospital, something like, from a patient presenting with a symptom and problem to getting primary care to a hospital admission to a discharge to rehab. So these are spanning usually multiple business processes, the way that we often think about business processes, and involving multiple actors, multiple applications, data across multiple repositories, and often crossing organizational boundaries to the extent that the enterprise itself is virtualized. The inspiration for these comes from mission threads in the defense context, and some work that was done at IBM Rational in green threads. And what they did at Rational was looked at, how does a user go from using rational tools to design a product, to deploying it on a Web3 application server, to using Tivoli to manage their systems. And here they were looking at how many times does somebody have to write something on a Post-it note, carry it over to another console, and enter that information. So from that, we've come up with this idea of looking at end-to-end through the enterprise system of systems as a useful analysis tool. So this business thread is a set of steps that occurs throughout the enterprise. We found 3 categories of business threads that are useful to think about. One is your core business. These are the core business processes of the enterprise, the way that the enterprise makes their money. If it's a for-profit enterprise, or their primary mission, if you don't want to think about it in terms of dollars and cents. And the processes that I listed on the previous slide are examples of core business threads. And often the way that you get these is by splicing together already documented traditional business processes. Then we have operations threads, and by operations here I'm referring to IT operations. If you're in a defense context, operations has a different meaning. But here we're talking about IT operations. So these are things like day-to-day management. So these are recurring things. One-time events, like how do we migrate our data into the system, or what happens on go-live day, and what's our process going to be in transitioning the application or systems to go live. We'll also look at maybe things that should never happen, or we hope never happen, things like disaster recovery. And the way we find these is to look for processes in your idle books or your data center operations manuals, places like that. Third category, development threads, tracing through development, test, and integration. So looking at development plans as a starting point to define these end-to-end processes of how do we go from requirements to systems that are actually running. Since we defined this original categorization, some things have been happening. There's emerging technologies like DevOps that are combining development, operations, and core business in ways that kind of blur these lines a little bit. So this approach is, or this categorization is a starting point, but not something that you necessarily want to get completely hung up on. Also thinking about business threads, 3 types, and these are somewhat analogous to if you've used our approaches with scenarios for quality attributes. We create use case scenarios, growth scenarios, and exploratory scenarios. 3 different types of scenarios. For our business threads, we look at as is. These are threads that capture the current state. You would use this to identify quality attributes, quality attribute requirements that you want to preserve as you evolve the architecture. Look at 2B. This is the target state in your enterprise architecture. And these are going to reflect new capabilities. They're going to lead to new requirements. And then what if kinds of threads. And these are analogous to growth scenarios. They're going to explore opportunities, test the limits of your enterprise architecture. Now, if you've used our approaches with scenarios for software systems, a majority of the focus there is on use case scenarios, sort of the core operations. Here, that's not necessarily the case that you want to focus exclusively on as is. I think our experience has been that, if anything, most of the focus is on 2B scenarios. What's your future capabilities that you're working towards? You backfill and create as-is business threads in order to capture current state in areas that you want to preserve. And what-if threads are used really as the business needs to look at opportunities and testing some worst-case scenarios.
Okay, folks, we have a quick polling question on your screen now to get everybody involved. And the question we'd like to ask is, we deal with quality attribute requirements, A, systematically, B, partially, C, barely. We'll wait about 15 more seconds for everybody to vote, and then we'll show the results. Okay, John, we got 18.9% systematically, 56.2 with partially, and 24.8 with barely. So, obviously, a large majority with partially or barely. I'm sure that's no surprise.
Yes. Yeah, when we talked yesterday, that was pretty close to what I predicted. So, good. So we have a representative audience out there. So, what do we do with business threads? Well, by themselves, they're just a sequence of steps. They're a platform that we can use, though, to improve our understanding of quality attribute requirements. Again, the goal here is to get to something that is actionable for architects, something that we can use to make decisions. And the Business Thread Workshop, or BTW, need to abbreviate everything. So the BTW is a facilitated stakeholder-centric method that takes the business thread steps and augments at each step what are the relevant quality attribute considerations. And in the course of doing this, we also capture architecture challenges and some functional or capability gaps. Many of the challenges that we find are rooted in architecture mismatch, and these can be syntax between two systems. One system is sending ASCII, the other system wants to receive Unicode. Where there's syntax mismatch, or semantics mismatch. What does pick a term, sold? We say a product is sold. What does it mean in each system? Does it mean we've received the payment yet or not? Different systems, different meanings create mismatch in our architecture. The Business Thread Workshop, it's somewhat analogous to the Quality Attribute Workshop for software systems. However, the scale of an enterprise architecture leads us to conduct these in a little bit different way. Often in a system and software setting, we'll do one or maybe two quality attribute workshops. In an enterprise architecture, there's a series of business thread workshops, and this may be even an ongoing process. And it's going to depend on scope, scale, schedule, stakeholder, time and budget, other kinds of considerations. So, whereas the quality attribute workshop is more of a one-time event, this is much more of a sequence or an ongoing. So just a little bit about the process, the inputs to a business thread workshop. Well, remember, we started off by saying that architectures are created to satisfy business and mission goals. And so the first input is a presentation by a business owner that outlines the business goals and the quality attributes that they think are important to achieving those goals. As we move from software systems to enterprise architectures, this presentation can be easier or harder. Some enterprises are extremely crystal clear and consistent about what their business goals are and very open about sharing it. Other enterprises are maybe not as open about sharing what their goals are outside the executive ranks, or there's some fragmentation across the business, and different parts of the business have different goals that are not well always aligned or reconciled. And so that makes it hard if we're trying to develop an enterprise architecture to achieve our goals, and our goals are somewhat fragmented. That can make the architect's job very difficult. So there may be cases where the inability to get consensus on what our business drivers are precludes really doing a whole lot of work on creating an intentional enterprise architecture. Other inputs, architecture plans, business context and business threads are the execution steps. And one other difference between this and the quality attribute workshop is that we want to identify the business thread steps before the workshop, whereas the quality attribute workshop, we get everybody together and develop the scenarios on the fly. We find that developing the business threads beforehand is more efficient. And then we go through our augmentation process. So for each of the business threads, we look at overarching, cross-cutting quality attribute concerns, security, interoperability, things that cut across many steps, and capture whatever assumptions and issues we know about. And then step through the thread, and at each step, we record the relevant quality attribute considerations. All right? So essentially, at each step, we're developing a set of scenarios where the stimulus for the scenario is defined by the steps that we're going through, and we engage our stakeholders to identify the response and response measure. All right. And it's a facilitated process. Stakeholder engagement is absolutely critical to get to a consensus. One of the things that we found is we go in with processes that are documented, and when we get our stakeholders involved, you hear a lot of, well, that's not really the way that it happens. And so sometimes the steps themselves need to get adjusted during the workshop. The outputs from the business thread workshop, overarching quality attribute augmentations, and then the step-by-step augmentations, and then the architecture challenges. So what do you do with all of this? Well, you can use this to assess feasibility, cost, and schedule. Do we proceed with our plan, or do we adjust requirements or scope? The quality attribute requirements themselves flow into the architecture design process. And again, at each step, we're essentially developing little scenarios that we can use to analyze and evaluate the underlying systems and infrastructure. And the other use of the business threads is to evaluate the enterprise architecture. So before we move into a discussion about evaluating the enterprise architecture, we have another polling question.
Okay, our second final polling question today, folks, is we evaluate our architecture, A, systematically. We do it for every project. B, partially. We evaluate selected projects. Or C, barely. We don't really evaluate our architecture before construction. Take about 15 seconds to vote, and we'll review the results. Okay, again, about 80% answering B or C, partially or barely. So I'm assuming, again, no surprise there.
All right. All right, well, that being the case, then, if you did want to evaluate your enterprise architecture, a few perspectives you might take. At our practitioner workshop in 2010, we identified several perspectives. So the first is enterprise architecture is a process. And so let's evaluate the quality of the process, and good processes produce good results. So use an approach like CMMI or Gartner or others do process evaluations. Second approach is the enterprise architecture process is carried out by individuals and teams. So evaluate the competence of the people and teams and organization using a method like our architecture competence assessment. Third is business processes are first-order elements in our architecture. So look at coordination theory to look at how does our operating model align with our processes. And people thought these were all reasonable approaches. Fourth approach, to quote John Zachman, the father of enterprise architecture, he said, architecture is architecture is architecture. And so take a scenario-based method like the ATAM and extend it to the enterprise architecture level. And actually that last one is the approach that I'm going to discuss today. Other approaches, depending on your context and organization, may be appropriate, but we'll look at the last one, and enterprise architecture evaluation. So the approach that we have been taking is to take a system of systems perspective, to say that this enterprise architecture is built as a set of systems, and perform a first pass or top level identification of risks and quality attribute inconsistencies. What do we mean by first pass or top level? What I mean there is it's not exhaustive. We're going to focus on the overall enterprise architecture, a selected number of business threads, and the result of that may be more detailed analysis of the constituent systems or interactions between the systems. The approach balances the depth and breadth of evaluation against the limits on stakeholder time and attention and architects' schedule and budget. So conceptually, it's similar to the architecture trade-off analysis method, where we take scenarios and walk scenarios through the architecture for a software system. Here we're going to take business threads and walk through the business thread and look at how does the architecture support the steps in the business thread and achieve the quality attributes that we've attached at each step. Again, it's a facilitated, stakeholder-centric method, and we're going to be identifying the top-level concerns and then using that to drill down into other constituent systems. So tying it all together, we have business thread workshops. We talked about enterprise architecture evaluations and drilling down into our constituent software systems. So we always start with our business drivers up in the upper left of the slide. And then from those, we're going to define a representative set of business threads and conduct a number of business thread workshops that are going to lead us to these threads augmented with quality attribute considerations. We're going to use those threads to design the architecture, use those threads also to perform enterprise architecture evaluations. Based on the results of the enterprise architecture evaluations, we're going to identify risks. They may cause us to rework the architecture or cause us to want to drill down into the architectures of the constituent systems or the interactions between them. And all of this feeds the process at the bottom of the slide that develops the enterprise architecture, the architectures of our constituent systems, and overall systematic risk management. So going back to the slide that we showed at the beginning, we build enterprise systems to achieve our business and mission goals, and architecture being the tool that we use in the middle to express those the business and mission goals in a way that we can implement the systems that we need and evaluate the architectures to satisfy, show that we're satisfying our business and mission goals. So before we go to questions, I just want to acknowledge the work of my colleagues in the Architecture-centric engineering initiative. The material that I've been presenting today came from our collective work in architecture over many years. And in particular, the business thread workshop and enterprise architecture evaluation builds on work that Mike Ghilardi and Bill Woods started in the defense system domain. So thank you for your time. Shane, go to questions.
Okay. Again, everybody, thank you very much for attending today. Before we get to the questions, we'll push out one more survey here as we get closer to the end of the Q&A session, as your feedback will help us on how we did today and improving future events. Lots of questions about slides and a recording. The slides are available on a widget in your console. If there's any issue with the slides in that console, we'll have a follow-up email that's going out tomorrow that will give you a direct link to the slides, and also when the recording will be available later this week. So look for that information to come out tomorrow. So we'll get on to some questions for John here. Let's see here. From Mahendra asking, what are the unique ways to assure the sustainable performance attributes of architecture as living systems delivering life cycle performance?
Repeat that.
And let me repeat that one more time. From Mahendra asking, what are the unique ways to assure the sustainable performance attributes of architecture as living system delivering life cycle performance?
So I go back to the first diagram that I showed, that we're creating architectures in support of business and mission goals. And so using methods that allow us to express our business and mission goals in terms of quality attributes, with performance being often a key one of those, and then evaluating the architecture itself, because the cost of change of an architecture, although high, is a lot less than changing the systems that we build using that architecture. So a systematic process of looking at business goals, translating them into quality attributes, making architecture decisions, and then evaluating those architectures back against our business and mission goals as an ongoing process would be the way that we recommend doing it.
Okay, next question from Christopher asking, can you share any thoughts about strategies for creating an enterprise information repository that tracks business threads, quality attributes, and systems relationships?
So we can't make any specific recommendations at this point. As I said at the beginning, this is ongoing work. It has proven to be valuable in its current form, but it isn't yet complete. And so some of the things that are still open research issues for us, one is coverage. How do we assess how well business threads are covering our architecture? And the second is what are the relationships between all of these artifacts, and how do you manage them in a sustainable way?
Okay, a question from Nancy asking, can you describe better what are the needed artifacts to be successful in replacing, and she lists PT to PT, so I'm thinking that's point-to-point interfaces, with not addressing data, content/vocabulary, required levels of data, computability required for new semantic interchange specifications. And if you need a repeat, I will gladly do that. So let me read it one more time so you can get your thoughts here.
Yeah.
Can you describe better what are the needed artifacts to be successful in replacing point-to-point interfaces with not addressing data, content/vocabulary, required levels of data, computability required for new semantic interchange specifications?
Well, I'm not sure if this will answer the question, but we've had some recent experience working with a customer where it became very clear to us and the customer that the relationship between the data architecture, the application architecture, and the business process architecture. So we have business processes are performed. We have applications that automate or support those, and those applications produce and consume data. And those three perspectives, three architectures need to get dealt with concurrently. You can't change the business processes without impacting the application of data. You can't change your data without necessarily changing the business process that produces it. I'm not sure if that exactly answers the question, but taking a holistic approach to at least those three parts of your architecture is critical.
Okay, hopefully, Nancy, that answered your question. If not, feel free to type back in and we'll look at it again. Next question from Devi asking, you talked about SOS architecture and enterprise architecture. How about the architecture of large software products like SAP? Does this also fall under enterprise architecture?
So systems, SAP, Oracle, and the like, are part of an enterprise architecture. We broke the enterprise architecture support down into four pieces: data, application, business process, and infrastructure or technology. Certainly something like SAP is defining your data, or a big part of your data architecture, and your application, or a big part of your application architecture, and is going to leak into your infrastructure, and to the extent that you don't want to go customizing it, is going to impact your business processes. So it's certainly a big part and one of the significant decisions in your enterprise architecture, or decisions or constraints, something like SAP, Oracle, any of those enterprise application systems.
Okay, next question from Mohammed asking, what kind of stakeholder engagement strategy can be formulated for enterprise architecture based on an extended ATAM? Or it says extend ATAM?
Yep. Well, so the enterprise architecture evaluation method that I presented briefly is an extension of the ATAM. And that's certainly one place to engage stakeholders. Business Thread Workshop at the enterprise architecture level is also a key place, maybe even more important. For people that aren't familiar with the ATAM approach, it's a multi-day stakeholder session where it begins by engaging stakeholders to define the scenarios, and then the architects walk those scenarios through the architecture and show how the architecture satisfies the scenarios. Because of the complexity of enterprise architecture, we really need to deal with creating the scenarios of the business thread, doing that quality attribute augmentation as a separate process. And that's the Business Thread Workshop. So that's really a place to engage your stakeholders, and then bringing them back at the evaluation time to show how you're addressing their needs in the architecture is a closed-loop way of engaging them.
Okay, question from Siva asking, can we effectively use BTW for existing enterprise architectures to improve their quality attributes?
Definitely. You can use Business Thread Workshop on an existing architecture. The thing about the Business Thread Workshop is it's a little bit architecture agnostic. It's focused more on what needs to get done. And then you can take those business threads, augmented with quality attribute considerations, and look at your existing architecture informal or formal way. You can use your existing architecture to create the as-is business threads, and then work from there to your 2B state. So definitely plays well with existing architectures as well as...
Okay, question from Futoshi asking, today you explained about evaluation methods for system boundaries between users in the system. I think we must evaluate two aspects. Boundary for users, in parentheses he says outer, and internal structure, parentheses, inner. How about the latter one? Is it enough for the first one to be evaluated?
Okay. So business threads, we look for an end-to-end perspective, but there are, so the two ends of the business thread are facing end users maybe, but everything that happens in between is internal. So all of the various steps that we go through are internal to our system. So the business thread actually does support both user-facing and internal evaluation.
Okay, next question from Andreas asking, is it possible to quantify the risk of not doing architecture evaluation?
Quantify, no. But we do have experience and anecdotal evidence of the value of performing architecture evaluations. But one perspective on architecture evaluations is it's like an insurance policy. And, what's the value of an insurance policy? What's the value of a life insurance policy if you don't die during the period that the policy is in effect? So, a little bit difficult to quantify, but certainly it's there. Value is there.
Okay, and the last question, then we'll let John off the hot seat here, from Cheryl asking for more information on quality attribute scenarios. Specifically, she'd like you to explain how do the quality attribute scenarios complement the use cases?
So, as I mentioned, use cases talk about the what needs to get done. Quality attribute scenarios identify the how, the qualities that we need to attach to that functionality. So usually if we've got a set of use cases, they will turn into stimulus events that we then build out quality attribute scenarios around. And I'd also refer her to the Software Architecture and Practice book by Bass, Clements, and Kaisman in the SEI series that goes into some more detail about quality attribute scenarios.
Excellent, John. Thank you very much for your presentation.